So I'll do this in my typical fashion of using live coding and code samples. And whenever I get lost, I'll just try and look at the documentation, see what the documentation says about Java optionals. But it will just be an exploration of what optionals are as a language feature. So let me get my, okay, I already have IntelliJ here. So I'll just create a compact file. I don't know if I need a package for this. Let's just, to be safe, let me make one. So this is optionals, and I'll have a main class, optionals main, optional main. So I'll use a compact file, so that allows us to have more space for exploration, more room for checking things out. This should be in here. Although I doubt I even need the package. Yes, just all habits. Okay, just kill that. So the first thing we are going to do here is do an overview of what optionals are. Optionals overview. Then I'll look at how optionals relate with nullability in Java. This is optionals. And then I'll look at how optionals relate with Java streams. The streams feature that was added in Java 8. And then look at how you can abuse optionals, or at least what can be considered an abuse of optionals as a language feature. So let's start with what you can do with the language. Let me just check the stream, see whether there is. Okay, so let's start by checking out the language feature. So there's several ways you can create an optional. Well, one of the ways you can have an optional, and maybe before I go into how you can create one, what really is an optional? So an optional, you can imagine it as a box that has two states. So it's a box with two states, kind of like Schrodinger's cat. What is that field of physics? Schrodinger's cat. That is from. So there's relativity, and then there's the other branch. That name has escaped me. Yeah, quantum physics. So so you can imagine an optional like the cat, where the cat that contains, the box that contains the cat. So that box has two states. Either it has a dead cat or it has a live one. So optionals in Java act as a box that contains two states. That is, it can have a value or it can be empty. So it's a less extreme form of the Schrodinger experiment. So it's a box that has two states. So it's either empty. Or it contains a value. So that is what an optional is, and that value can be any type in Java, but optionals are object types. This is something very important to know. So optionals are boxed types. So it means they have a reference somewhere in memory for the actual value. So when you're using an optional that's wrapping a value, you're kind of using double reference. So in memory, you'll have a reference to the optional, and then the optional will have a reference to the value it will have a reference to the reference of the value it contains, and then the reference to that value will have a reference to the actual value. So internally, that's what the memory layout might be for optionals. But the main thing to remember is that they're box types, which means they are more punitive in terms of memory consumption as compared to regular null values. And you'll see a lot of comparisons between nulls and optionals in the language. Some people look at them interchangeably, but they're actually different. So let's start with a simple optional example. So you can have an optional integer, and this optional integer is just an optional that can or might not have an integer. And the way you initialize an optional, you can use optional.off and pass in the value. So this has the value 32. This is an optional. So this is how you can create an optional. You can use .off to initialize an optional with a value. You can also initialize an optional that's empty. So empty optional here will have optional.empty, and this is an optional that doesn't contain anything. There's another way you can initialize an optional. You can specify that the optional can contain a null value. By default, optionals are not supposed to house nulls, but there's an API in the language that allows you to specify special cases where you need to do that. So you can have a nullable optional by calling optional dot of nullable, and here you can have a null value passed into that optional. What happens if we call .off and specify a null? Then there should be a runtime check here, and we'll actually explore how the language deals with these two cases. And with the nullable optional, you're able to check for nullability. And we'll see that in when we get to extracting a value. So these are three valid ways of initializing an optional that are valid in the language. Let me see if there's any runtime exceptions. So no runtime exceptions. Let's see if we use .off with a null. Yeah, so if you use .off, optional.off and pass in a null value, so this is a regular optional. If you pass in a null value, you get a null pointer exception at runtime. So you're not allowed to have a regular optional that contains a null as its value. So it has to contain something. And this is important because if, let's say you have a function void get student, or something like get config, and what this returns is, so this returns an optional of type config, like so. And let me just make it public. So if you have a function like that, and of course we can define our config, and our config is just let's say a key value pair. So it's a map of key, maybe string, and a value. The value is probably just string as well. So so this is the so it's a config that has a key and a value. Okay, let's call these entries. So you can have that record that is a config, and you call a function getConfig. And what this getConfig function does is it returns an instance of config. So new config, and the config here, of course, is a map. So you can use map.of and pass in some entries. So let's say the config here we have is password, and the password is that pass. Maybe it's you have IP address, and the IP address is some value 127.0.0.1. So this is a valid config, and you can return it from this function by, of course, using one of the initialization techniques. You can say optional.of conf, and that will return config, an instance of config, and that will be config with some values. So if we're using this function in our code, we might say var config is equals to getConfig. But this config function is unpredictable in that it returns an optional, which is a signal to us that the return value might or might not have a value, might or might not be empty. And let's create a situation where the return value is empty. So let's say there's a flag that we are passing here, and the flag could be perhaps it depends on the operating system. So let's say is Unix maybe. So if it's a Unix system, we're able to return this config. If it's not, we return an empty optional. This would be a situation where you'd normally return null. So you would do something like if is Unix return null. But in this case, we'll return optional dot empty. So now we know that our function getConfig can give us back a valid config with the password and the IP address. But in cases where we are not in a Unix environment, it will return empty. So if it's not a Unix environment, it will return. If it's a Unix environment, it will return empty. If it's not a Unix environment, we'll get the password and the IP address. So I just added the branching there to demonstrate that in cases where within your function, you decide that in this function I'll return an option that doesn't contain a value. This might be how we would normally write it. And of course, here we can pass in a Boolean value. So let's say we pass false. So if we pass false, we expect that our optional will contain a value. But if this is true, our optional will not have a value. So yeah, there's a way you can, okay, let's just have this static. So if this function is an API that we are using and we are not sure, perhaps this is Unix operation is an environment function, so we can't strictly predict cases where we'll get an empty or cases where we'll get a value. You'd be tempted to use the config directly. So so for one, we can't use the config already as it is. I think to better demonstrate this, let's have an old school implementation of, quote unquote, old school implementation of how this function would look like. So regular, let's call this get config legacy. So this is before Java 8. This is what you do, or at least before they introduced optionals. So you'd have the function there, and of course you can do the check. And if that check, if it's a Unix environment, we can return null. Otherwise, we return this config. In fact, we can do that in line. So otherwise, we would return that. So this is how we would write it in a legacy code base. And this is how we would write this function using when we're utilizing optionals. So if we are calling the legacy function, like the get config legacy, we could go ahead and attempt to use our config here. Maybe let's say get entries, and we try to do something with the entries, like we could obtain an iterator entry set maybe, because it's a map. So we could get an entry set, and then we could probably iterate over the entry set. Separate those calls so that it's config entries, and yeah, so we could try and do something with these config entries. I just use for each to loop over. I don't know why the ID is completing this for me. So this would have the key and the value, and what we want to do is just perhaps do something with that key and the value. So in a more simplified case, we would, okay, so this is the entry set. Yeah, the entry set has the key and the value. Yeah, I think that should work. So we can print the key here, denoted with K. And we can print out the value. Okay, we already have the entry set. So this is one single entry. So I'll denote that with E, and within the entry we can get the matching key, and we can get the matching value. Call get value on that. Yeah, so this allows us to loop over the entries from this map and print the keys and the value. So in this case, we are calling the legacy function. Let me just get rid of some of this. And if we execute that, we'll see that we have the key password, this value, and the value is that, and IP address is that IP address. So with the legacy version, we can do that. But what if we are not in a Unix environment? So in this case, we pass in. So what if we are actually in a Unix environment? So we pass in true. So initially this was false. So false is probably when we're in Windows or something. To make this a bit more realistic, let's say we have like a current OS variable here, and the current OS variable is Windows. And what you can do is, when passing the value of whether we are in a Unix environment or not, we could say if current OS dot content equals Windows, then we can say so that is not a Unix environment, otherwise true. And so if we are on Windows, the function should be able to work. as expected. But if we are in Linux, which is a Unix environment, then what happens? What happens is we get a null pointer exception. So we get an NPE, and we get a null pointer exception because we explicitly return null. And since we didn't check for that null in the config value, of course, at runtime, we get the system completely crashing on us. So normally, the way you'd remedy that is you could do if config is not equal to null, then do something, or you could actually do a guard statement. Maybe say if config is equals to null, then return, which means the rest of the function would not be executed if the value you got from that call is null, just to avoid risking the null pointer exception. So optionals makes this a bit more manageable. And to demonstrate that, let me just wrap this implementation into some other function. So let's call this void usage legacy usage. So I'll wrap that there. And now let's write this with optionals. So with optionals, we can have the same case. We have the current OS, or we could just say the OS is, and I'll start with Windows. So that's the operating system. And then instead of calling get config legacy, would call get config. And this would give us a config by calling get config. And of course, we can use the same operation that we did last time. You can say content equals Windows. But we could say if os dot starts with win, then we would say we are not in Unix, otherwise we are in Unix. And so this would give us the config, but the difference between this config value and this other config value is that this is an optional. So being an optional, we can be assured that one, it won't be wrapping a null, because as we saw earlier, if you try to wrap a null, it will fail at the function level with a null pointer exception. So we are fairly confident that it won't be wrapping a null. And the other thing we know with optionals, or at least we should assume, is that the language will give us APIs to use to avoid unexpected failures, other than using a conditional statement, which is what we've done with the legacy version. So let's see what happens here. So we could do the same thing we did with the conv, but in this case, we'll just be checking for whether there's a config value or there's no config value. And the way you do that is, so optional provides this get function, and get allows you to extract the actual value, extract the wrapped value. But before you extract the wrapped value, it is important that, let me just, so it's important that before calling get, you do a check on the optional. Kind of the same way we've done with our legacy version. We checked whether config is null before we attempted to use it. So you kind of have to do the same thing with optionals. And the way you do that is you use a function in optionals called is present. There's some additional variants of this, but this is the most popular one. And if present just returns a Boolean. So it will return true if the optional has a value, otherwise it will return false. So so if you call is present, the internal behavior is if a value exists, you get true, otherwise you get a false. So it's like a ternary operation, sort of, or it's something like that. So if the optional has a value, you get true, otherwise you get false. And with that knowledge, you can craft a conditional statement that calls is present. And we know that this will return true if there's a value. So if is present, then we can safely call the get function. So we can safely call config.get because there's a value present. And we know that this value will be the actual config. So if we did that, we would actually have the config. Why am I having issues here? Oh yeah, I'm reusing the variable name conf, which I shouldn't. Oh wait, so this is the optional config. So maybe I can prefix it with the opt-con for optional config. And that will allow me to reuse that variable name. Yeah, so you call get, and a get will attempt to extract the actual value. So what if you call a get and don't do the check? So calling get and not doing this check for whether a value is contained is the same as not doing this null check and just using conf. So if you do this, you'll end up with a null pointer exception. So you get an NPE here. The only difference with the optionals is instead of an NPE, you'll get a different exception class. I think it's element not found or something like that. So essentially what you need to remember is that you'll get an exception. And I think we can actually demonstrate that. So we don't have a value here and we call get. So let's create a situation where we would have a value. So if it's Unix is when we return empty. So let's say this is Linux. And if I run it, I'll see that, yeah, I get no such element exception. So not really element not found, it's no such element, which is not very different from a null pointer exception. The only difference is in the name. So the only difference is in the name, but it's, you could consider this a null pointer exception since they all behave the same way. It's an exception class, it's a runtime exception, which means you won't detect it at compile time. So it's very important to remember never to call get before checking the optional for a value. If you call get and you don't check whether the optional contains a value, then yeah, your system will only work on your machine. And that is one problem that Docker won't be able to fix. So that will be one of those issues where you just have a system that fails in production. And if this is undeterministic, maybe it depends on external variables in your system, then it can create a situation where you have some very difficult to trace errors. So your system fails and you can't trace where that failure happens. So it's very important to know this early on, make it a code smell. So if you see any part of your code calling get here without doing a check for whether a value is actually present in that optional, then you can deal with it, or at least correct it before it creates some unexpected failures in production. So now we know we should not call get before calling is present. And what is present will do is that it will check that there's a value before, so that we can have a safe call. So this is safe. So we can safely call get and obtain the value. And of course, we can use the value to do the same thing we did here with the other implementation. So we can call conf dot entry set, since it's a map. Okay, so that's the entries, and I can get the entry set and call for each on that entry set, and we can print out the values just like we did in the other function. So this would be the key. Since they are both string, I could start with the key, element get key, and the value here can be element dot get value. Not very different from what we did here. Yeah, so that check is very important. Of course, the IDE is able to evaluate that since I've already set OS to Windows, this check will be irrelevant because it will always be a non-Unix system, which means it will always return a value. But of course, without the IDE, if you're in a case where the outcome is undeterministic, then doing this check becomes very critical. And of course, you shouldn't rely too much on the IDE anyway. So since I used Linux there, I don't get anything printed. If I use Windows, then I'm not getting a value printed still. So if it starts with that, then false, and then optional config dot is present. What am I missing here? Okay, get config. So in this case, we'll be passing false. If we pass in false, then we'll have the config, and then we're just checking that the config has a value, and if it has a value, then we get the entry set and call for each and obtain the value. And this should work. Starts with win. Oh, okay. It's case sensitive issue. So I'm using uppercase W for Windows, but it should be lowercase, I think. Yeah. So it's starts with this case sensitive, and I don't think there's an equivalent starts with ignore case. It would be nice if there was something like that. But of course, you get there's equals ignore case. Yeah, there's equals ignore case. That will ignore case, but this will still work for us. You could also do a different. You could also take a different approach and call to lowercase on this, and of course, get rid of that. So that will convert this to lowercase before it does the check. That should make it work still. Yeah. So we're able to do that check. If you want to create a guard statement, like we did with the null check, there's a variant of if present, and that is empty. And is empty will do the opposite. If value exists, it will return false. If value doesn't exist, it will return true. So it functions like any other call to is empty. So we could do what we could do here is if optional config dot is empty, we can do an early return, And then that allows us to get rid of this branching here. So we can get rid of that, and instead of having the branching, we have a bit more straightforward code, like so. So if it's empty, it will do an null return, otherwise it will print the values. And of course, if this is something like Mac OS or OS X, we'll see that we won't get a value. So it does those checks. And so that's the bit you need to always remember when you work with optionals. Before you call get, do an is present or is empty check first to ensure that the optional that you're using is safe to access. Otherwise, if you call this get blindly without doing a check, you end up with a cousin to null pointer exceptions, which is no such element exception. At the bottom line, you end up with an exception. It won't matter to the user which kind of exception occurs. They'll just know that the system failed. So that's how you safely extract values from an optional. There's other additional methods that you can use to extract a value, but before that, there's another guidance thing that we need to know about. Is since optional is a reference type, I could just go ahead and return null here, and I will not get any compile time checking for this. So this is dangerous because now when I'm using the optional, it doesn't matter whether I do an is empty check or is present check. This will always be a null value returned from this get config function. And in fact, I think if we run it, you'll see that. So get config, optional config is empty. And so this is a null. So optional config is null essentially. Actually, I was expecting to get a null pointer exception at this step. I'm surprised that it even goes as far as allowing me to call is empty on it. But because that is the is empty function is available on the API itself, I guess that's why that would work. Let's see what happens if we call get. Okay, we still get no such element. So I think there's some safety mechanisms inbuilt. So you could return null for an optional and not running the risk of getting a null pointer exception when you're trying to check it for value. So you could still do is present, you could still do is empty, but it's this is a very unpredictable behavior. And it's important to, oh wait, I think I'm influencing the outcome a little bit here. So let me change this to Windows. I think I might be giving the JDK more praise than it deserves. So if we do that, okay, yeah, so you still end up with a null pointer exception. So because this is null, so when we return null for the optional, since it's not a primitive value, we can still return a null value for it. If we attempt to do is empty, yes, if we attempt to do is empty here, we get a null pointer exception. So it's always important to remember that optionals are not a replacement for nulls, and it's also important to remember that they are reference types, which means they can be null. So it's very important to be aware of that that problem. Of course, there's talk of there being support for primitive optionals. I've never used them. I've only seen them in the in the JEP that introduced optionals at the language. Let me just make sure this is back to normal. But there's a way you can have primitive optionals. Let me see if I can find the JEP for that. So essentially what you potentially get is, instead of just the optional, which is boxed type, box type just means is a reference type, like your regular Java objects. There's primitive optionals like optional int. You can have optional double, and the optional int and the optional double will actually be primitive types that behave like regular ints and regular doubles. Let me just check the docs for that. Optional int Java. Yeah, so this is the PI. Optional int, final class int, extends object, interesting. So a container object which may or may not contain an int value. So it may or may not contain a primitive int. If a value is present, you can call this present, will return true. Get as int will return the value. So let's assume, still want to use this config. So let's assume our config contains an int value here, and the int value is, in this context, let's assume it's usage count, something like that. So let's assume that's usage count for like how many times that config has been used, and it's an int, so that means within this optional we can have that usage count, but we do something interesting which is not advised. Within our this is totally yeah, you should not have like optional fields. So let me try and come up with a different example. Let's have a different function. So let's have a function here that returns an optional integer, and the optional integer is, so it returns an integer which can be empty or can contain a value, and what that value is, maybe let's assume it's usage count. And for it to calculate the usage count, you pass it. Okay, let's assume we don't. No, I'd like to control what happens in here. So let's assume we pass it. Let's pass it the operating system. So the operating system name, and it will calculate the usage count value depending on the operating system. So let's assume, just like in the previous example, if you pass it an operating system that is Unix based, so if element equals ignore case to Unix, so if it's a Unix based system, we just return optional.empty. Because let's assume the function doesn't have the ability to calculate usage count for a non-Windows based operating system. And so in the case where it's not Unix, we do a calculation, a very complex calculation here, which is just obtaining a random value and returning it. And of course, we need to wrap that value inside an optional. So you can do optional.off and wrap the value that we want to use. Yeah, so we wrap the value, and yeah, so when somebody calls get usage counter and passes an operating system, if it is Unix, we'll return empty. If it's not, we'll return an int. So let's try and use this function. Let me get rid of this, move it to a separate scope. So void legacy. So this is opt1. It's just a random name. Doesn't matter. I just want to keep the code. So you can call get usage here, and you can have a variable which is the operating system, and the operating system can be Windows, and pass in the OS, and based on the value of the OS, we'll get a count for usage. So we'll get a count for usage, and we can use that count for usage to like print out that value. So we know that this being an optional, we shouldn't just extract the value directly. So we should not do get directly on this. Instead, we should check whether there's a value first. And we can do that with a guard-like statement, or we can do is empty. So you can do is empty and return. So early exit. If not empty, then we can get the actual count by calling usage dot get, and that will give us the count, and we can print that count. So the count is usage. Yeah, so if we run that with so we run that with let me see, let's print out the operating system as well. So OS usage. So Windows usage is that number. You could do a bounds here. So let's say this is 0 to 1000. To set the bounds for this random number generator. Okay, yeah, so we pass the bounds to the actual call for the value. So it's like 0 to 1000. Yeah, so Windows usage is 513. Of course, this is just a random number, so nothing much happening. So yeah, random, if you look inside, you'll find that it's deterministic. Yeah, so it's a fancy algorithm. And okay, so it's using bitwise operations, which means I will not understand what it's doing internally. But the common rumor is these random number generators are usually deterministic. There is secure random for cryptography, which is rumored to be somewhat closer to random. But most of them are usually deterministic. So you can more or less predict the value that you'll get from the random number generator. Yeah, anyway. So what we know is we are getting a random number from that, and that becomes our usage count. So the other things remain the same. So you can call is empty on that optional. You can call get. But now there's this API optional int, which allows us to use primitives for optionals instead of reference types. And let's just see how much different this can be. So instead of returning optional, but let's have a variant function. Public optional. So this will, instead of returning optional, will return optional int. So it's already, we've already locked in the type signature. We know that the optional will wrap primitive int. So we don't need to specify the parameterized type here. And we call get usage. Call this get usage primitive. And of course, just like the other function, we pass in the operating system. This condition will remain the same. So just do equals ignore case to Unix. If that is the case, then we want an equivalent of optional.empty. So optional int empty. Okay. So that remains the same. So we can just call empty to return an empty optional int. And in the other cases, we can return the actual value. So I think we can still do optional.off. If I did optional.off with a string here, that would not work. If I did that with a character, that would not work. So you have to have an integer value. So we can invoke our random number generator, just like we did, and give it bounds. So this is from 0 to 1000, just like the other case. And so this gives us a primitive optional. And a primitive optional, I don't know if you can see, this is wrapping an integer, a box type. And anybody familiar with generics in Java can see that, can understand that we cannot wrap that with a primitive int. We have to use a boxed type like integer, which means I use some additional extra memory for the headers and for the pointer that will actually point to where the actual int is stored, because with box types in memory, they are reference types, which means there's some overhead. And of course, you get to deal with issues like garbage collection and stuff like that. Because they are box types, the garbage collectors do occasionally come around and clean them up. But with primitive types, they are layered directly in memory, so you don't need heavy use of GC to clean this up. But bottom line, primitives are faster than boxed types. So when you get an opportunity to use a primitive, you better take it. If performance is something you are, performance and efficiency is something that you are concerned about. So this is good. It's good that we can use a primitive with optionals. That can become super helpful, especially when you're doing performance optimization. So now, if I knew how to use Java Flight Recorder, we could profile these two functions, but I don't know how to use Java Flight Recorder. Maybe I'll learn it one of these days. But I just know that this would be faster than this. Of course, speed depends on how heavy the usage is. Sometimes the difference is negligible. If the system has 1 GB of memory and you're using an extra 8 bytes for optional integer, or you're saving 16 bytes if you use optional int, it might not make sense in the context of 100 gigabytes being available. But if your system is constrained, or the function itself, when it's being executed, has so much data that if you save 16 bytes for each value, you end up saving like 100 megabytes for that one operation, then it might make sense to jump into some of these optimization opportunities. But it's good to know that you have that. This is really good. So now, just like we did with the other function, Again, just like I did last time, let me wrap this up. So the reason why I do this is so that at the end of the stream, I can share this code on my GitHub instead of it going to waste. And if I did something that is interesting to you, you might go back to it and review it. Or I gave up on telling people to leave me feedback. People are too busy with their lives. They don't have time for sending me feedback. So the best I can hope for is that you will see a concept here that is interesting, and you'll go back to the code to just play around with it and see whether you can learn something. So now when we call so we can do an isempty check, and also when we can call get, which interestingly has some variants. Of course, we'll look at or else get and or else. That's for later. But the interesting thing here is there is get as int, which is a very interesting discussion. The reason why it's interesting, first of all, let's use it first, then I'll tell you why it's interesting. So this will give us an int. Let me just have it declared as int to be sure. Var can be deceiving sometimes. And usage, this is usage, use B. So if you run that, we should get the same effect. And of course, we can get fancy with it, have it prefixed to the operating system. And if we run that, we get Windows usage is 995. Of course, these are random numbers, so it will just change randomly. But the difference is this is an integer and this is an int, which means you're saving on memory, you're saving on performance. So very nice. Okay, let's talk about why this is called get as int and it's not called get. So when the optional API was introduced in Java, one of the mistakes that was made was to use, or at least I'm calling it a mistake because the guy who designed it called it a mistake. That is Stuart Marks. So it was a mistake because the Java collections framework already depends on this get function. So if I have, just back this up, or I could just back it up later so I don't lose my stream of thought. So if I have a list of integers, let's call this ends, and it's just a simple list. Yeah, contains an integer 1, 2, and 3. I can call get on this list, and of course pass in the index. Maybe I want the first integer, and it will give me an integer. So on the left side, we'll have an integer. Let's call that p. If I have a set of doubles, for example, so if I have here a set of doubles, let's call it SB, and I call set.off, and it has doubles. It has 3.1, it has 1.2, it has 5.3, so this is 1.2. I can extract a double from this set, double value from this set by calling the set get function. Wait, can't call get on this. SB. What? I can't. I can. Okay, so how would I extract a value from the set? Okay, this is How do I get a value from? I thought you could call get on a set. Oh, like a glitch in the matrix. I've always known that you can call get on a set to extract a value. Because essentially all collections wrap an array. So although we have sets, we have maps, we have lists, we have linked lists, internally you have an array, which means all the values are still stored on an index-based format. So this is very strange. I didn't know that I can't call. Let me check the API documentation for set. I don't want to lose this. Java doc set. So there's add, there's clear, is empty, you can get an iterator. Oh, wow. There's no get function. You cannot get a value from a set. You can iterate the set to retrieve values. Yeah, you can get an iterator, but you cannot just pass it an index. And okay, this could be because this could be related to the fact that sets are not ordered collections. By ordered collections, I could be using that term incorrectly, but what I mean is with a list, you have arrangement that follows insertion order. So your values are stored in the way you insert them. First in, last out. No? First in, first out. So if you store an element at index 0, other element at index 2, other element at index 3, you can extract them by those indices precisely. You can say, I want the value at index 0, and it will give you the value that we inserted at that particular index. With sets and maps, the order can change. So the insertion order is not preserved when you are extracting value. So you cannot do set.get at a particular index. Which might explain why that get function doesn't exist, because the only thing the set could do otherwise is if I call get, then it would give me a random value because the order is not preserved. And I guess this is the case also with maps. Okay, silly me. So let's use lists to demonstrate this. So back to the discussion on this get as int. So because when you call get in normal Java APIs, the get function gives you a value. But if you call get on an optional, you might have an empty, or you might have the actual value being returned. Using that function name loosely could cause problems in the language, in that the perception that get always gives you a value or a null, or no, not even a null. If you call get on this list and that index doesn't contain a value, of course, you'll get an index out of bounds or something like that. So the perception is that get is not a conditional call. It can either succeed or fail. So when you call get on something, it should always either give you a value, or internally there should be like an exception, which to their credit, they still achieved that with the no such element exception. If you call get and the value, the optional doesn't have a value, it will throw a no such element exception. But reusing a function that is already being used in the collection framework and reusing that name for an operation that is similar to what the collection framework does with get can create a conflict of concepts in the language itself, where now you have the Java collections library conflicting with the optionals API. So to remedy that, At least on the last talk I watched on this from Stuart Marks and Ryan Getz, is there's a suggestion to have a get or empty function. So this would be a call on the optional to retrieve a value, but if the value doesn't exist, then it would give you back an empty optional. Because optional.empty is essentially a valid type. In fact, in our case here, we call empty on an optional int, we're able to get some representation of that, which is this empty type. And the empty type is just an optional that has not been initialized with a value yet. So on the left-hand side, we could have an optional int. And this optional int can either have a value or might not have a value. So for us to be sure that it has a value, we might try to access the value after doing checking whether the value is present or not. So I think in my own view, that is why get as int is labeled as such, and it's not just a regular get. It's the language designers trying to be very explicit about what this function does, which is it does get the regular get that we're used to with optionals, but it doesn't return any value. It returns a primitive integer. So it's being very explicit. And maybe that's also reflected in the documentation. So if a value is present, returns the value, otherwise throws no such element exception. Return type the value described by this optional int. Okay, so the documentation is not as explicit as I thought, but the function is self-documenting. So you won't get an integer from this, you'll get a primitive int. So that's an interesting piece of law, if I can call it that. So it's kind of related to the lists issue. So anyway, we're able to call get as int, and this will give us a primitive int, which is very important to know. And we can achieve the same effect with doubles. So you can have a function that returns an optional double. So if performance is critical, do this, don't do this. If performance is something you're thinking about. So let's say this gives us, perhaps it's the same function. Java supports function overloading, so I don't know if the correct term is overloading, but essentially you can have a function with the same name, but if the signatures are different, okay, not the return type, the signature in terms of the function arguments. So if this has something else like a value there, we could still use the same name. But in this case, we want the same arguments. So I'll extend the name a little bit. So this should give us the double equivalent of what we did here. So os.equals ignore case. So if it is Unix, then we return optional.empty. Otherwise, we return optional with a value. So the only difference is we can't use optional int here, so it's optional double, and of course this will be optional double as well, and it should wrap a double value. I don't know why it's accepting an integer, because this gives us an int. So this is int rand new random value bounds 0 and that. Yeah, so this is an int. I wonder why it's entertaining the integer. It's doing automatic casting. Let's see. Yeah. Okay. So it's casting it automatically to double. So I guess that's what's happening. Yeah. So, but essentially, what we we able to get here. I could be more specific here and just use next double. And just to be more explicit. And this is optional double dot of that, and this will give us the double equivalent of that operation. And we could do the same thing that we've done with primitive. Extract this to a different location. Void opt3. So we can extract that. It will be largely the same. We just pass in the operating system, and we're able to get a value from it. So this will be get primitive double. And you see now the get as int function is not available to us. Instead, we get as double, and this will return a primitive double, not a boxed one. And it automatically checks for is present. If that fails, there's no such element exception. Okay, this is very interesting. So it's actually doing this is empty check for us internally. So you don't even have to do it on your own. Although I kind of don't like this, because it's probably better if it's consistent with the regular optional API, because it forces me to assume that that check will be done internally, and I don't need to do an is present check on my side. And when I'm doing it, I'm wasting CPU cycles because I'm repeating something that the language has already done internally. But let me just be sure of that. So this means we can get rid of our check here. Of course, this gives us a primitive double. It's D for it. And if we run it, we'll see that we get the random double value. Now, so if this is ugly, you could do C-level formatting. You could call string.format and pass in the formatting you want. So perhaps you want this to be 2F, and pass in the double. I'm supposed to pass in float here, but I'm expecting automatic casting will take charge. And this will be truncated, not rounded off. Yeah, you can print the truncated value. Yeah. Oh yeah. I think I still need to have the decimal. Yeah, so that will be 2 decimal points, so that it doesn't look too crazy. Since it's random, it's just multiple values. So this get as double function is doing an isEmpty check internally. Does it mean we can play dangerously with it, and we won't get that no such element exception? So let me pass Linux, and the function works is if it's Unix. If you pass in Unix, we should get an empty, which means if this is doing the check internally, okay. If it's doing the check internally, then it's still not very useful, because it will just throw no such element exception. So the API is consistent. I even suspect the get is also doing the same thing. So it will check whether the value contained is null. If it's null, it will do no such element exception, which is, so you can see how it's bypassing doing the null pointer exception by intercepting a case where we would actually get the null pointer exception, and instead we get a no such element exception. So the API is consistent, whether using optional primitives or the regular optional, box type optional, or reference type optional, you still have to do that check. Otherwise, it will fail. So I guess if we run this, we'll just get that. You get no such element exception because it's intercepted. Our call is intercepted when we do get, and Java is able to check whether there's a value there, and if there is no value, it will throw the exception. So to be safe, we need to follow the advice that we're given for this API, and we need to an is empty check. So we can do is empty or is present. Any of them can work, but I like guard statements because they allow you to, one, reduce branching, and two, the code is more readable because I can stop reading it here if this value is empty. I don't need to worry about what happens after because I know that nothing will happen after this check if this check fails. So, and also I don't like branching. It makes code, in my opinion, not very readable, especially when you have nested branching where you have if, then you have a condition, then inside that you have if, and then you have some other condition, and you have an else. Maybe you have an else if, and this wraps another condition. I think this leads to ugly code, and not necessarily. The main problem is not that the code is ugly. The main problem is you cannot reason easily about that code. You have to like take a pen and paper and start trying to find the state diagram for for what is happening in the function. But this is clear. If this fails, just don't do anything else. Just don't touch anything. This is more like don't touch anything if you're not qualified. So if this variable is not qualified, we won't even think about what happens here. Anyway, so that is optional primitives. I don't know. I think they're limited to integer, int, double, and maybe float. So you can get optional float. Optional float. Do we even get float? No. So it's just optional int, optional double, and optional long. Maybe the API documentation has them listed. So they're under java.util, and java.util is crowded. It has a lot of things, but maybe I can be lucky enough to be able to see the difference. So let me look for something in util. In fact, I'll just look for optional int. Okay, so yeah, so we have optional int, which is the class we were checking out. I see the getters int function there. Increase the font here. So we have getters int. Sorry, we have optional int. So there's optional, which is the regular optional. This optional, it's generic, parameterized type. So optional double, which is primitive. Yeah, so this is primitive double for when you want an optional of primitive type double. GitHub. Come on. Oh yeah. So then we have optional int and we have optional long. So it's limited to this. It's limited to these three types. But this is only for a moment. I think the language is heading in a direction that this will not be limited to just that types. There's a project that is introducing something called value types in Java. I think it's Project Valhalla. And with the value types, we will have classes that behave like primitives, which I think will flow over into having the same relationship we have with the regular optional and optional int, optional double, optional long, being available to um, to every aspect of the language and even in developer code. So you could write code that's similar to that, where you have an optional that has the functionality that the boxed optional has. For example, is empty, is present, you have the get function, but it behaves like a primitive type. So yeah, so I think this is under Valhalla. Yeah, so types, values, and variables. So it says a Java programming language is a strongly typed language, which means that every variable and every expression has a type that is known at compile time. That's a good thing. Types limit the values that a variable can hold or that an expression can produce. Limit the operations supported on those values and determine the meaning of the operations. So strong typing helps detect errors at compile time. Very important. JavaScript people are suffering for lack of that. Of course, there is TypeScript that kind of tries to bring this. And PHP, before PHP 7, the type system was also kind of broken. But having strict types is a good thing. The types of the Java programming language are divided into two categories, of course, primitive types and reference types, what we just saw there, with the optional double and the regular optional. The primitive types are a Boolean type and the numeric type. So you get Boolean, you get long, int, double. The numeric types are the integral types like byte, short, int, long, and char. And the floating point types like float and double. The reference types are class types, interface types, and array types. Of course, like records, if you have a class student, class config, that would be an object type. Interfaces, of course, and arrays. There's also a special null type. An object is a dynamically created instance of a class type or a dynamically created array, the value of a reference. So dynamic because it has a reference to the actual value. So you can move it around without changing the value it's pointing to. The values of a reference type are references to objects. All objects, including arrays, support the method of class object. So everything imports from java.lang.object. Extends from java.lang.object. String literals are represented by string objects. Okay. So this is just describing the existing type system. Let me try and get to the juicy part. Integer operations, floating point formats, floating point operations, Boolean type and Boolean values. Okay. Yes. Okay, no. Come on. Parameterize. So this is within generics, get parameterized types. Very common, like the regular optional that we saw here. This uses a parameterized type, like so. So this allows you to make this T anything that is object type. It can't be primitive. It can be anything, but it can't be primitive. It can be anything that is not a primitive type. So this is a rabbit hole that I hope to cover one day on this stream. I thought this document was talking about Valhalla. I don't think it does. value classes. Oh, yeah, in fact, it's not value type, value types, it's value classes. Yeah. Yeah, so value classes and objects are a transformative new Java feature currently being developed for inclusion in the future JDK release. Value objects are instances of value classes which have only final fields and lack object identity. Very important. The latest early access build is published. So value objects model immutable domain values. A value object is an instance of a value class declared with the value modifier. So you get a value keyword. Developers can save memory and improve performance by using value objects for immutable data. So I guess this immutable is also important. It could be, I think they'll sort of behave like records, except they won't be reference types. They'll be primitive, and the type being the value being immutable, I think allows the JVM to do internal optimization that allows them to emulate primitive behavior, although the user end code appears like a regular Java class. Yeah, interesting stuff. Let me stick to the topic of the stream, which is optionals. So we've seen how to initialize an optional with the off of empty. We've looked at primitive optionals. So I think the other thing we should check out is nullable optionals. So if I have a function here that returns an optional string, we haven't used strings, and the string here is, let's say it's a message, and the message depends on the int value, which is a signal that you send. So you send a signal, you get a message. If you send the wrong signal, you don't get any message. And how we check the signal is if the signal is less than 5, or just making this up as I go. So if the signal is less than 5, or the signal is greater than, if the signal is less than, let's have a range. So if the signal is, if it's less than 5 and greater than 0, then we send a message. Otherwise, we don't send a message. But in Java, if your if statement spans less than not more than 1 line, you can skip the curly braces, which is nice. So if not, then we return empty. So now that we know that we can do, what did I just import? So now we know that we can do optional.empty here to return an empty value, and here we can return optional.off, and this will contain the value that you want to return. But in some cases, you might want to wrap a null value inside the optional, which is, of course, breaking the rule that is optionals should not wrap nulls. So in some cases, you might want to wrap null, which I think we actually looked at such a case earlier. So let's say if the signal matches, instead of returning empty, we could decide to return null. And the way you do that, you call optional.e of nullable. And in this nullable, let's expand the logic a little bit. So we can call of nullable here, and we can do a second check on this signal and check that the signal. So we already checked that it's greater than 0. Signal is less than 5 and greater than 0. So less than 5, greater than 0. So if it is greater than 3, we could do a null value. Otherwise, we could do an actual message. So here we can do the actual message, like hello, you passed. So let's assume this is some kind of test. And okay, so I already called off nullable. So we won't be wrapping it with an optional. So what we have is you can call off nullable, which means the value inside the optional can be null or it can be an actual value. And the third case is if this initial condition fails, we just return empty. So the way we would use that is, let me wrap this. Call this opt4. So the way we would use this is we can pass in a random signal. So this is a random signal, and I'll reuse random here, and I'll give it the bounds 0 to 10, of course, just above the 5. And yeah, so that is a random signal, and we can call message passing in the random signal. And what we know is once we call the message, we'll get an optional message, which means that message can have a value or it might be empty. And being that we want to write safe code, you can do some defensive programming here by saying if it's empty, then return. Otherwise, we'd get the message by calling message.get. So this, normally this would give us the message. I'm not interested in args there. I don't know how that happened. Anyway, so this would give us the actual message, and I can print out the message. So in some cases we'll get the message, in some cases we won't. And think to prepare for that, instead of just having a blank display there, we could print something when we don't have a message. Perhaps invalid signal. Yeah, so this is a case where you don't have the message. Some cases we get a message depending on the signal we passed in, and maybe the message could contain the signal, sig, just to make sure that our logic actually matches what the function claims to be doing. So we don't get a message there, and then we get a message signal 1, signal 2, signal 1 again. Yeah, so we can do that, but also we know that this optional can wrap a null if on top of getting a potential empty, we can get a potential optional that has null wrapped in it if the signal we send is greater than 3. So if I was to change the bounds of this and say this is between 4 and 10, so it's more likely to pass in a value that's greater than 3. So if we run it, let's see in the first case we get invalid signal. Let me check the condition. Okay, so we already have a less than 3, a less than 5 here. Okay, so since we have a less than 5, we pass in 4, 4 is less than 5. that's greater than 0, so that goes in. But 4 is greater than 3, then we should have a null. So I guess what's happening is that I'm not using that 4. Let me just pass it in manually for the test. So if I pass in the 4, so 4 is less than 5 and it's greater than 0, but 4 is greater than 3. So this should be wrapping a null. So I'm expecting to get a null pointer exception here instead of invalid signal. So why am I getting an empty of nullable? Okay, so I think if the optional is wrapping a null and you call is empty will check whether the value it will check whether the value contained is a null, and if the value contained is a null, then it will fail. So it will behave the same way as if you are returning optional.empty. Which optional.empty just means the value wrapped inside is a null. In fact, you can see it's initializing an optional that contains null. Okay, so that's really important. I didn't expect it to behave like that. Otherwise, and this actually might lead into the other thing, into the other way people use these optionals, is if you suspect that you might have a null value, you can wrap the value that you received inside an optional.of nullable. And what the optional will do is that when you get a null, instead of throwing a null pointer exception, when you call is empty, it will check whether the value that's wrapped in is a null. And if it's a null, then you have like a safeguard here that protects you from extracting that null value. It's one of the ways you can abuse the API. You can use it as your implementation of nullability checks, something that in languages that like Kotlin would be like, if I declare a variable, if I have like an integer number here, and if it's of type int, I could use this question mark symbol to indicate to the language that this is nullable. So anytime I try to access number later on, the language would force me to either force cast this or have a safety check for when the number is actually null. So you can wrap your values. So in Java, you can wrap your values with an optional.of nullable if you suspect that those values can be null, and that will give you a language level API for checking the null without using if value is equals to null, then. So you get something elegant. But of course, that's not advised to do. It would be better to be explicit and just do a null check if it's a null check that you are looking at, so that your language is self-documenting again. If something has the potential to be null, it should be clear in how it's being used that it has the potential of being null. If you wrap it up into an optional that's nullable, it might create a notion of the value never being nullable, because the nullability is defined inside the API that I'm calling. So inside messages, when I'm defining this as a nullable optional, but the value I'm returning from this function to the caller, this is just a regular optional. In fact, it's just an optional that's wrapping a string. It's not an explicitly nullable optional. It's just any other optional. So this becomes hidden capability to the user of the function. But if you want your APIs to be more explicit, it's probably better if you avoid usage of that of nullable to wrap values that can potentially be null, so that the API also remains with one core function, which is to wrap values that might or might not contain a value. So it's empty or there's a value present, not empty, there's a value present, or that value is a null or a null. So you avoid a situation where you have three potential cases, which is demonstrated by the example we just did. So in this message, we can have an empty message, an optional that is empty, which is an empty message. We can have an actual message like hello, you passed, or we can have an optional that is wrapping a null message. So yeah, that complicates things. So it's best if the API is simplified. So if we wrote as a more clean version of this API, you can do optional string, and of course this is the message. So let's say this is the clean version. So clean message, and of course it receives a signal. I'll do the same checks. So let's do a check there for the signal. Signal is less than 5, or signal is greater than 0. And if signal is any of those, then we can return optional dot off the message, hello, you passed, and the signal is the signal. And of course, else we can return optional dot empty. So if we want to handle the third case, which is a case where, yes, the signal is less than 5 and greater than 0, you can just add another condition here, which brings in branching. But in this case, I don't think, at least for now, it's not very obvious to me how you can escape the branching. But we can do if signal is greater than 3, and this if signal is greater than 3, we can have a different behavior. Otherwise, we can have the same behavior we have here. So we can have that, or we can have hello, you almost passed, and of course including the signal. So you can have more explicit code like this for such cases. And now if we call clean message, if there's no value, we'll get invalid signal. But if there's a third condition we want to handle, it will be handled explicitly, like in the case where you pass in the signal form. And it's always good to be more explicit in your code. Don't write fancy code because when you write fancy code, even your future self won't be able to understand what you are doing. And when you have bugs, it becomes a nightmare because the code is so complex that even you don't want to go back to it and start fixing issue. Okay, so we've done a really thorough deep dive of optionals. I don't know if there's anything we missed with optionals. We've looked at how to initialize optionals. We've looked at how optionals behave with the nulls and the relationship. We've looked at primitive optionals. I guess the other remaining thing would be to look at how the optionals work with streams. But before we do that, let's check out some other APIs in optionals that we still haven't looked at. So of course we've looked at the null check, but there's a more streamlined version of doing this null checks, which is to use some APIs in optional. So let me just archive this implementation. Opt 5. So there's a function we wrote here that allows us to get a config. I'd like to use that for this example, at least for this next step. Let me bring it closer here to this. So this is a call to get config, and it has the potential of returning a config. I want us to advance this example a little bit by modifying what a config is. So I hope I can do that here. So we can have the regular config, but the thing I want to do with this config is, instead of the value being a string, the value will be another config. So that means you can have like a nesting of configs, where one config makes a reference to the other config. I like to do it in a way that doesn't change up this code too much. So in this case, the key is the value, and then the value is config. So so the password will point to a config, and the config is a value, and the value of that config is another config. So okay, this can get to okay, this can get a bit too nested. Let me just use a different data structure for this next part, because I could still modify it like that, but I already have some code here that I'll need to refactor it. I'm not looking forward to doing that refactor. So in fact, let me just create a separate file here, because a compact file, and let's call this optionals around 2. So I'll use a different record. So we can have a record, and this will be a record of a painting, and the painting is the name of the painting, and we can have the painter, which is another object, and we can have a serial number of the painting. So let's imagine this is a piece of software that is used in some art gallery or an exhibition. Record of the painter. So you can have a record of the painter, which is just their names, and maybe their age. Nothing too complex. So we have a pretty solid record there. So we can have a list of painters, but a list of paintings. Paintings is equals to list.of. Instead of list.of, you can also use arrays.aslist to create the list. If you use list.of, it becomes unmodifiable by default. Arrays.aslist also has the same behavior in that you cannot change the size, but you can change the individual elements. So here we can have a painting, and of course the painting will be Van Gogh. Let me get some names of paintings. Painting. Popular paintings. I think Van Gogh is the painter. Uh, uh, okay. Mm. Yeah, so there's Starry Night by Van Gogh. So let's imagine that's our first painting, Starry Night by Van Gogh. I think that's how you spell it, Van Gogh. So that's the painter. Of course, the painter is a more complex object. There we have the name of the painter, and we have the age. I don't know how old he was when he did this painting. Let's assume he was in his 50s. And I think that should do it. So we have a painting, the name of the painting. Oh, of course, the other thing, we have a serial number. Yeah. Let's have another one, maybe by a different painter. Girl with pearl earring, 1665. Okay. Mona Lisa, yeah, by Leonardo da Vinci. So I can have Mona Lisa, Mona Lisa. By Da Vinci. Da Vinci. Let's assume he was maybe young or 40s, maybe. People didn't live that long in their time, so maybe he was 27. And our serial number there. So, so this is our list of paintings, and we can create a stream from this list. So you can do paintings dot stream, and that will give us a stream. And within this stream, we can do some processing. We could do a filter to find all the paintings done by Da Vinci. So you can do all the paintings, label it P here, where P dot painter dot painter dot names dot equals ignore case to Da Vinci. And once we do the filter, we could just return the list of paintings, or we could decide to map that and get the painting names instead. So you can call a painting, the idea is being very intelligent here, painting name. So yeah, I'm just using method reference. In essence, what this is a similar lambda that we had there, except we are calling painting dot name, like that. So that's what we are doing, except we are using method reference for a shorter experience. The problem with syntax sugar like this is if somebody reading, the person reading your code doesn't know what this method reference thing is, then they won't be able to understand your function. But if you're confident that whoever is reading your code knows what's going on, then yeah, you can be rest assured. So we can also do, I think we can do a reduce function here. Yeah, or we could also do collectors.join. So I don't know if I can call, yeah, I need to call collect first and joining, and I can pass a split rater, like a delimiter. So what I want is we'll get all the paintings, and we'll find all the paintings done by Da Vinci, and then we'll have a comma separated list of those paintings, like a CSV. So this will reduce to a string, if I'm not wrong. Oh yeah, the value is ignored. So this will reduce to a string value. Let me use something explicit. So painting names. So at the end of the day, what we want from this is the names. And yeah, we could print those names. You could do something more explicit, like for string name in names. Oh, I can't iterate. Okay, so it's already a single string that's comma separated, so I don't need to do an iteration. So this can allow us to print the name. So yeah, we only have Mona Lisa. So if we had more than one painting, I don't know if there's another painting by Da Vinci. Yeah, okay, there's another by Van Gogh, which is Irises. That is Irises. So Irises by Vincent Van Gogh. Let's say he did this at 17. Was very talented. So if we applied the filter with Van Gogh, and executed that, we'll see that we get Starry Night and Irises, which is the list of paintings that were done by Van Gogh. Now, let's imagine a different case where instead of just getting the names, I just want, we want the first painting, any single painting, let's say, done by maybe Da Vinci. So we are fairly confident get any single painting done by Da Vinci. So we are fairly confident that our paintings list only has one painting, but we want to use stream processing for that to get that one painting. So we can do the same operation we did. The names here are the names of the paintings, and I can reuse that variable. And you can say paintings dot string, and we can apply a filter, and our filter will just check the painting, get the painter, and once we check the painter, we can get their names, and we can check if their name is equal to Da Vinci. And if the name is Da Vinci, then we can find the first painting that matches that name. So you can call find first. So interesting thing with find first that we need to be aware of is it returns an optional. So if the list is empty, it will return an empty optional instead of a null. It will give you an empty optional, and you can do checks on that optional so that you have safe use of streams. So find first, which will give us an optional. So if this painting doesn't, if there's no painting here done by Da Vinci, we want a safe way for this stream to execute the next part, which is this mapping function. So how do we do that? So we could do map and just try and get the name, and once we have the name, of course, call collector, and call joining and pass in our separator. Of course, I need to reference collectors, but I could do a static import here. Okay. In this context, it might be tricky to do a static import because I don't even have a package structure. I'm using a compact Java file, so it's much safer to do this. Yeah, so of course, this won't work because this mapping function doesn't guarantee that I'll have values to collect. So what do? We could say if you don't get a value, this find first doesn't return a value, we could return a placeholder. And this is where some functions within optional become useful. So optional has this function dot or else. And what or else allows us to do is if there is no value in that optional, we can pass in a default placeholder value. The placeholder value is what will take the place of a situation where the optional was empty. So we could say if there's no value, we could say no painting found, something like akin to like an error message. And so this will give us a string. And now, since we have a single string, of course, we don't need to use collectors because this is already reduced to a single string. We don't need to do a reduction operation. So we can get that. So what will happen here is we'll attempt to get first. Then we can call map so that if that value is present, then the name of that value will be extracted. Otherwise, this map will just give us an optional string. It will just convert an optional painting into an optional string. I like how the IDE is doing it here. And if this optional string doesn't contain a value, the final non-optional value of that string will be replaced with no painting found, and that will become the value of names. So now if we print this, since it's just string, just go ahead and print it. Let me get rid of that. So if we print that, we'll see that we get Mona Lisa because, of course, Da Vinci has Mona Lisa on the list. Let me try and query a painter that we don't have here, like Gustav Klimt. So if I query Gustav, that's Gustav Klimt. We see no painting found. So instead of getting like a null pointer exception or no such element exception, instead we're able to intervene and have a replacement value for this. In a more obvious example of what I'm doing here, so that you understand that it's not limited to streams, is if I have an optional integer, and this is optional int, and my optional int, let's say initialize it with an optional with a value like 321, I could very well do but let me make it a bit interesting, and let's use our randomization thing to make this a bit interesting. So, or perhaps not too random. Okay, let me not make it random. Just end up being more confusing than it needs to be. So optional dot int, which contains the value 321, we can have an operation here that extracts the actual integer. So var int or value int, which is the int wrapped by the optional, And what we can do is we can do opt-int dot or else and have a different value like 0. What this line summarizes is this kind of operation. So it's equivalent to doing opt-int dot is present and sorry, it's empty. Oh yeah, it's empty. So it's empty, and if it's empty, replacing the value of var int. So let's say we declared var int up here, call it val int, and we initialize it with maybe we initialize it with nothing. Just make it an int that's not initialized. So we can say if it's empty, val int is 0. Otherwise, we can initialize it with the value that we obtain from the optional. So we check whether there's the optional contains a value. If it contains a value, we initialize val int with that value. Otherwise, we, in fact, so this is not, or else this would be get. So otherwise, we query the optional and obtain the actual value and use that to initialize val int. So this here is a summary of this. Okay. So that's how we use or else. So you can do opt-int dot or else, and this will change the value that would otherwise be empty with an actual placeholder value. So var value would be that. So if this optional was empty, if this is optional dot empty, and just get rid of this, and we printed the result of that operation, if we did dot print line val, we should see that if it's empty, we get 0. If it's not empty, it has a value. If it's not empty, if it has a value, let's say 33, then we would get 33. So that is the purpose of or else. The other variants of or else, so that is actually the same operation that we are using in streams. So at this juncture, we just do or else, and if there's a value here, we'll return the value. Otherwise, we'll replace the optional with an optional that traps this value. So the only difference here is, in fact, we won't be replacing it with an optional, we'll be returning the actual string value. What we end up here with is a string. No, we still get an optional. I was expecting it to be a string, because in this case we are getting the actual int. So with streams, it's different. I think when we call or else, we'll still get an optional. Oh, the problem is that I'm redeclaring the string. It's not difference in behavior. So IntelliJ, get out of the way. So if I did already have this here, so this is string. So or else will actually return a string value. It won't return a string wrapped in an optional. And if so, this guarantees that we always return a string, which can be no painting if there's no painting found, or the name of the painting if there's a painting found, just like we saw the Da Vinci example. So there's other variants of or else. There's or else get, which allows you to pass in a lambda, and that lambda will, so this is a supplier. Let me remind myself first what a supplier receives. So a supplier, of course, is a functional interface. It doesn't receive a value. All it does is it operates and returns a value, which makes sense. So use the supply in cases where, so in a case where the optional is empty. So let's try and have an example here. So it's a lambda that doesn't accept any arguments. Instead, it does an operation. So it could do, so it does an operation that returns a value. So it could do a random number thing, since we are working with integers. Next int, and that would be the purpose of the lambda. What is the problem? Or it requires an explicit target type. What if it's just a supplier? Supplier of type integer. Yeah, so that would be our lambda. You can pass that in there. And what this will do is get rid of the other example. So what this will do is it will attempt to extract the value from the optional. But if there's no value present, it will use this lambda to compute a value. So let's have a value here. And let's print this in different cases and just see what happens. So since our optional contains the value 33, we get to print 33. But if our optional was empty, we would get a random number, because this supplier would take over. So if the supplier was returning an explicit value like 1, and our optional is empty, it will return 1. So that is what or else get does. It allows you to pass in a supplier for the value that you eventually want to supply. There's other variants. So if I have an optional here of double, if I have an optional of double, let's call it op D, and it's an optional of doubles, and it has a double inside, like 32.11. We can call opd.orelse throw. So the or else throw has two variants. This just I think this will just throw no such element exception. So it will behave like a regular optional, nothing special. But there's a variant that allows you to specify an exception class that you want to throw. So or else throw, so this will allow you to pass in an exception supplier. So a function that supplies an exception. So this other supplier was supplying an integer, but you can supply an exception. For anybody who is familiar with lambdas, you know that instead of this, we could just do that and skip that extra step. Of course, it's highlighting that this lambda is not doing anything special, so we could make it do something quote unquote special like that. So you can still do this. So you don't have to have it like a separate variable. I was just putting it as a separate variable to emphasize the point that you can pass lambdas as variables, which if you know functional programming, that should be familiar. So the second variant of or else throw, of course, let's experiment with this first. So if our optional contains a value, double value, we call it db. So if it contains a value, you'll be able to print that value, db. Just run that. You see that we get 32.11. But if it doesn't contain a value, if it is empty, we'll see that we get a no such element exception, just like it is documented on that API. So if you look at the API, you'll see at least this is not necessarily the documentation, but the code is doing a really good job at documenting what is happening. So you don't even need to read the docs. because it will check whether there's a value. If the value that's wrapped in is a null, it will just throw no such element exception, which is the case when the optional is empty. Now you can decide to throw a different exception. Let's say this was an optional that was wrapping. Let's make it a bit interesting. So we have these paintings, and I want to reuse these paintings for that example. So what do I do? What do I do? What do I do? Let's have a function. Let's have a separate function. And this function returns an optional. In fact, this function doesn't return optional, it returns a painting, get painting. And it receives the author as the name, the painter in this case, as the argument. And of course, it has the list of paintings at hand. And what this will do is similar to what we did with the other example. We'll use the paintings to create a stream, and then we'll have a filter on this stream for the author, painter.name dot equals signal case to the painter. And we can use this painter so we've applied the filter. What we want to return is a painting. If there's a painting, and we are only returning one painting. So a painter like Van Gogh might have more than one painting, but we want to just return one. So we'll call find first. And find first, we know find first gives us an optional. So since it gives us an optional, we can decide to use that optional and wrap it, check whether there's a value, but we're using streams here, so it's good to do some data-oriented programming, so we don't need to do all of that in line. Instead, we can call or else throw, and since we know that we are dealing with paintings, instead of just throwing a no such element found exception, which might not make sense to the user of our API, we might decide to throw a custom exception class. So we can have a class no painting found exception. And this extends throwable. It just needs to extend throwable. And here, instead of just throwing a no such, so if we just use this, we get a no such element exception, but we want to use a custom error class that it makes more sense to the users of our APIs. We can decide to use the supplier technique, and this will return no painting found exception. So instead of no such element exception, we return a no. We'll throw no painting found exception. And since this was going to give us an optional painting. Yeah, so if there is no painting, then we expect this exception to be thrown. It seems I'm missing something here. Unhandled exception, no painting. Okay, I was not expecting to handle the exception. Okay, so since I'm throwing it, I'll probably need to handle. Okay, let's pass the responsibility to the caller. So the caller will handle a no painting found exception. So this is how you can design the API. So we try to look for a painting that matches the painter, but if we don't find a painting that matches the painter, that is, if this find first function returns an empty optional, then we throw a no painting found exception. If a value is found, then we won't throw the exception, we'll just return the painting. And we can see that in action. here by calling the function, use that. So you can call get painting and pass in a name of a painter like Da Vinci, and we expect to get a painting in return. So we are not getting an optional, we're getting an actual painting. If there's no painting, we expect there to be an exception thrown. And we can decide to handle this exception with a try catch, or we could pass the responsibility over to whoever will be dealing with it later. And what we can do is, we know that if line 32 succeeds, there's actually a painting, because if there's no painting, then an exception will be thrown, which means line 33 won't be executed. So in line 33, we can just print the painting details. Painting, and here I can just say painting dot name is that, and maybe print could do a better job with this. We can do, let's do text blocks, and this is name, and so there's a name, there's the painter. I keep using author, maybe author still qualifies, and the serial number, and here with text blocks I can use the formatting, and this will be the name of the painting, and this will be the painter, and of course their name, and then we can have the serial number like that. So if we execute this, we will see that okay, so no value present. Oh, okay, so this is related to something else. So when we execute that, we see we get name Mona Lisa, painter Da Vinci, serial number that. But what if we pass in the name of a painter that doesn't exist, like Claude Monet? Claude Monet. So if we pass in Claude Monet, we see that we get a no painting found exception. And with these exceptions, you can get fancy. You could have a public constructor here that receives the message, and I think you can call super and pass in the message. And now in the exception, we could say, so of course this happens when we don't have a value. So here we could say did not find any paintings by painter. And now we see that our exception class is no painting found exception, did not find any painting by Claude Monet. If we passed in a different painter like Lady Godiva, Godiva, we'll see that we see did not find any painting by Lady Godiva. So you get some custom exception handling even when you're working inside streams, which is one of the problems people get when working within Java streams, is you cannot patch in a try-catch thing within the stream. So you need a way of intelligently handling errors. And one of the errors is when you are running through the stream and you get to a point where there's no value, the value can be null, or the value is an optional and you don't know whether the optional contains a value. So do you terminate the stream, or do you just return a list of nulls, or what do you do? So I think this answers the question of what you should do. Call or else throw, either just do a regular or else throw, which will cause a no such element exception, or do an or else throw, pass in a supplier, and that supplier will return back an exception class that matches exactly what went wrong while using the API. Like in our case, if somebody passes a name that doesn't exist in our list of, of painters. Yeah, so that is that. There's one other API that we could look at. That is if present is if present is a little bit more, let's say, complicated than or else and or else throw and or else get, but essentially they do the same thing. It allows you to pass in, I think it's not a supplier, then it's a function, but it essentially allows you to determine if there's a value, do this thing. If there's no value, do this other thing. So yeah, so this uses a consumer. So you can do if present and then you pass in a consumer. And a consumer is a regular functional interface, except with a supplier, you return a value. With a consumer, you don't return a value. You just check whichever value is in the optional and you do something with it. So, so if present, you pass in, so this would be the actual value that was wrapped in the optional, and you can do something with that value. You could do value dot it's expecting a consumer here, io dot print line. Okay, let me do something math related. Math dot power, so 2 raised to the value. I think it's because I'm reusing the name. So value is already being used here. So if there's a value in this optional, I'll execute this power function. If there's no value, the power function will be executed. And once the power function is executed, I might want to print out the results. This is a square function. You can do io.println square, maybe prefix it with that, square. And let me move this a bit closer so that we can fine tune it. So in the first case, it's empty. So we don't expect to see any value for square. So if I execute that, we still have that example. Let me refrain from calling that function for now. Like I said at the beginning, I'll make these code samples available for anyone interested. Oh, so yeah, so nothing happens if there's no value. But if we have a value, like say 2.0 or 2D, which still qualifies as a double, we'll see that we get 4, which is 2 times 2. If we have 6, we see that we'll get 64. So it will execute that power function only if there's a value. So that's what if present does. And I think we can also use if present inside streams. So we could do if present here, and that will allow us to execute some function with the contained value. Although I don't know how it will play with because if I do if present, it will probably do a terminal operation such as printing the value, unless we do some additional. Okay, it's a consumer, so it won't even give us a value even if we were to do an operation. So this will create a terminal operation of the stream. So it's useful for when you want to do something at the end of the stream, if you're using this with streams. Yeah, so but you guys can see what you can do with it, at least at the foundational level. That's what if present allows you to do. Yeah, so we looked at or else get. We've looked at or else throw with a custom exception. We looked at if present. So we've looked at is empty, is present, of null, of nullable, of, and empty. So I think that covers it. That's what you can do with Java streams. Yeah, looks like we've covered everything. So for those who have been here, I hope you've learned something. Personally, I'm very tired, so I think I'll stop it at that. If you haven't subscribed, make sure to subscribe. I do these Java exploration videos, streams, sometimes daily. My goal is to go over some of these enhancements to the language that were done pre Java 9. So Java 8 came with a lot of changes. So going back and looking at some of those changes, I think even optionals came with Java 8. And of course, the more recent changes to the language, like pattern matching, things like sealed interfaces, and such. And of course, Spring Boot. I do some Spring Boot sometimes. So make sure to subscribe. Otherwise, I think I'll end the stream there. And thank you for joining the stream. And have a good one. I'll try and make the source code available. Watch out for that. I'll post it here on YouTube. I'll also post it on my Twitter. If you follow me on Twitter at some programmers, you'll find everything there. Otherwise, this was fun. See you on the next one. Bye.